Hello children, welcome to channel Sube. Children, today I am going to discuss question number 43 from the MCQ part of 2022-23 Physics New Syllabus paper. The bottom surface of a cylindrical container of cross-sectional area capital A has a small hole of radius simple r as shown in the figure. When a liquid of surface tension capital T is filled in the container up to a certain height, the liquid starts to seep through the hole. The liquid is filled up to half of that height and an object is floated on the surface of the liquid. What should the minimum mass of the object be in order to seep the liquid through the hole? So there are 5 answers. There are capital T in the answers. And simple h is not there, height, area is, cross-sectional area is there. So let us start this. So children, I have drawn some diagrams to illustrate this story. So at first, the story is like this. Water is seeping, the cross-sectional area is capital A given. Suppose the height of the water column is simple h, and then they have reduced the height of the water column down to h divided by 2, so water is not seeping. So finally what they have done, a cube or an object is placed on the water surface so that it floats. Then from the hole water begins to seep like that. So that means the water, the height of the water column must be the previous value, that means simple h, the initial value. So this height should be there when it is the water is seeping again. So now we have to apply some theory to find out the answer. So since this cube or the object is floating, we can write mg. Suppose the mass of that object is m, mg equals upthrust. So we know upthrust is equal to v rho g. So now we have to use the Archimedes principle to find out the upthrust. So what is the Archimedes principle? So here is the Archimedes principle. If an object is immersed in a still liquid, fully or partially, the upthrust is equal to the weight of liquid displaced by that object. So that means the weight of liquid displaced. So this is the weight of liquid displaced, is given by this equation v rho g. So here v is the displaced volume of water. Displaced volume. Altogether this one is the displaced weight after multiplying by density and g. So if I mark that displaced volume here, so it is this volume. Initially the height was h divided by 2. Now this amount is the displaced volume. So the displaced height is displaced height is, now we know the additional h divided by 2 amount of water. So this one is due to this object h divided by 2. The height of that is h divided by 2. So now the displaced volume is going to be the volume now, displaced volume is this height times cross-sectional area. So this one is the displaced volume. So let us substitute it to this equation. Then mg equals, we don't want this u, let us neglect it. So instead of this v, we can substitute this volume h a divided by 2, then rho g. So this one is all this term, and it's equal to mg. So we have to find out this m. So here if you think about surface tension, there is an equation in a semi-sphere. The excess pressure we write delta P as excess pressure is equal to 2T divided by R, twice the surface tension divided by radius. So that is the excess pressure. So excess pressure is here P naught, the atmospheric pressure, here also P naught atmospheric pressure. The excess pressure is this pressure given by this water column. So that is H rho g. So excess pressure is H rho g. So we get an equation like this now. This one is the excess pressure. So this thing you learn in the classroom in the lesson surface tension. So in a sphere, the excess in a sphere means a water drop. Suppose a water drop like this. The excess pressure is equal to 2T divided by R. Here is that lesson, pressure difference in a bubble or curved liquid surface. So you must have learned this in the classroom. This is the equation. P2 minus P1 is the pressure difference. They have taken gamma instead of capital T for surface tension. So here excess pressure P equals 2T divided by R. So that is what we are going to use now. Excess pressure in a bulb is water drop is equal to 2T divided by radius R. So now we can use these two equations to solve this problem. Here we have gotten h times rho, that is not included in the answers. They have included capital T and capital A, so therefore we can't eliminate capital A, it should be here, and also capital T somehow we shouldn't get into this equation. We have to find out this m. So let us take this equation therefore to get the relationship with capital T, surface tension. So let us write this equation like so we can cancel first of all this G, then we get m equals h divided by, no, let us write A first and h divided by 2 and rho not G. So from here we see h rho part is here, this h rho part is here too. So we can take therefore this G to the left side, 2T divided by Rg, and isolate h rho and substitute it here. Then we get m is what we have to find out, A times, instead of h rho we can write 2T divided by Rg, 2T divided by Rg, and this 2 then at the denominator, so that cancel. Then finally m equals AT divided by Rg. Let us see the answers. AT divided by Rg. So the second one is the answer, AT divided by Rg. So children, this is how we should solve this problem. So children, I think if you feel any inconvenience because I took this from the lesson without showing it, so now I am going to show you how to derive this equation, that excess pressure equals to 2T divided by R. Let us take a water bubble or a water drop. So let us take the half of that, the equilibrium state of half of the water drop, water bubble. So let us draw the meniscus like this, the center cross-sectional area. So this one is the cross-sectional area, cross-sectional area. So the surface tension is acting this way, always it is towards the liquid. So around this perimeter there are these forces. So like this, around the circle, the perimeter, there are these forces. From the other side these forces are coming down. So the length of this perimeter is 2 pi r, that is the length. Capital T is defined as force per unit length. So the total force is then therefore 2 pi r times capital T. So this force is the surface tension force. Surface tension. But here what we want is not the surface tension, the reaction of the surface tension. The reaction of the surface tension is upwards. That is given by the brim of the hole. So it is like this. Like this upwards. So the magnitude is same. So what is this? The reaction of surface tension. Reaction of surface tension. So then, so now we have written one force acting on this semi-sphere. Then the outside pressure of this semi-sphere is P naught. Then from that pressure there will be a force towards this area. So the area of this circle is pi r squared. So this one is the area. On this area there will be a force like this. It is initially like this, perpendicular to this outer surface, but we can simplify it. Take the simplified components. So the horizontal components are cancelled each other, because we can write this force instead of this force we can write these two components in a perpendicular direction. So these horizontal components cancel each other, because from here also there is a horizontal force like that. So they cancel, only the vertical components are remaining here. So we have to consider that. So there will be forces like this, say green F, green color F. So that is equal to the pressure equals force divided by area. So we need force. Force equals P naught times area. So P naught times what is the area? We have to take this black color area, this one, phi r squared. So that is the direction of that force is upwards according to this diagram. So this force also upwards, because that is the reaction getting from the perimeter of the hole, brim of the hole. And also there will be another force from inside pressure. So there is a pressure inside here, because there is the water column like this. The tank is filled with water, so like this. So the external pressure is P naught, atmospheric pressure on this surface. So we assumed that this height is h. So here the pressure is P naught plus h rho g. Density of this liquid is rho. So then from that there will be a force on this cross-sectional area. So that is to this way, like this. That is also should be simplified as I explained previously. That also acting like this perpendicular initially to the surface, but we can simplify, take the components, and then horizontal components cancel each other, only the vertical forces are remaining. So that is what we are now considering like this. So this is the force given by the pressure. What is the pressure? P naught plus h rho g. P naught plus h rho g. So the force is pressure times area. Pressure is in brackets P naught plus h rho g, and then P naught plus h rho g times area. Area is this cross-sectional area, phi r squared. So that pressure, that force is downwards. So now let us consider the equilibrium state of this semi sphere. So downward forces must be equal to the upward forces. So downwards we have these forces P naught plus h rho g times phi r squared. Then that is the only force downwards, must equal to the upward force, this red color one, 2 phi r t plus this upward force, green color, upward force P naught phi r squared. So there are only three forces, this one upwards, and this one upwards, and this one downwards. This one is from the inside pressure, this one is from the outside pressure, this one is from the surface tension. So now we have to simplify this. So let us remove the brackets. P naught times phi r squared plus h rho g times phi r squared equals 2 phi r t plus P naught phi r squared. So whatever possible we can cancel. So phi we can cancel at first, then 1 r we can cancel from each term, then remaining P naught r plus h rho g r equals 2t plus P naught r. So P naught r we can cancel, positive, then h rho g r equals 2t, then 2t equals 2t divided by r equals h rho g. So that is the equation we used here. 2t divided by r is equal to h rho g. So now it is clear, you have no doubt now. So I explained how to derive it. So that is the result we used to solve that problem. As we did. So children, let us try. Now I think you understood all these things. Now let us try a simple target question, because we have no much time, because I had to do these all things. Children, here is our target question. Try to solve it without looking at my answer. Read the question carefully and start. After pausing the video, pause the video now. Since you have paused the video, now I am going to start. Children, the answer is the same. This one, second one is the answer. Even though it is a soap solution, you don't have to multiply it by 4 times. 4, you know, the excess pressure is, if it were a bubble, soap bulb, if it were a soap bulb, the lesson is here, you must have learned it. Excess pressure in soap bubble. If it were a soap bubble, the excess pressure is 4T divided by R. They have used gamma in this book instead of capital T for surface tension. So it should be 4T divided by R, the excess pressure. So you must have learned this lesson. So if you used that, it is wrong, because it is used for soap bubbles where inside medium is air. If inside is filled with air and also outside is air too, then you can use that equation. If it were like this, that means excess pressure equals 4T divided by R, not 2T. So, but here it is not the case. Here there is a water drop. Inside there is no air. Inside is filled with water. So here also water. So there is no any relationship with air. Only one surface is there in this case. But if it were a soap bubble, there would be 2 surfaces, air soap and soap air with water. Everything is filled with water. Therefore, you can't use this equation. If you use this equation and solve the problem, you might get something like this. So I didn't try. I can't say exactly, definitely something like that you might get. So the answer is this one, because you have to use not that equation. The excess pressure is equal to 2T divided by R8. So now children, time is over. Now I am going to wind up the video. Sorry, today we are unable to do 2 or 3 target questions. Only one we can do. So therefore I am going to wind up the video. So children, I think you are happy because I showed all these things, how to derive, and I revised your lesson too. So if you are happy, please subscribe my channel. Subscribing alone you is not enough for me, children. I told you in the previous video also, I have only 617 subscribes. To earn some little money, I need 1000 subscribes. So therefore, please, using your relations and friends, collect some subscriptions for my channel. That means You can subscribe by your father's phone and mother's phone and brothers, sisters, uncle, auntie, anybody's phone. Ask them to subscribe my channel. Subscribe and do it for me as a favor, as a help, because still I didn't earn a coin, because I am at this level, so I am not qualified to be paid. So therefore please help me collect some subscriptions for my channel, as I said, and also share my link among your friends and tell them to collect some subscriptions from their relations for my channel as a help. So then press the bell icon also, then you get the message as soon as I uploaded, and also like this video, then only this video is pushed by YouTube automatically. So do those things as a favor. See you tomorrow at 6 o'clock in the evening. Goodbye, good luck.